But we will record. It will pick up something. So this line here, 2x plus 3, how do I know that's the 2x plus 3 line? Good, because it's going up. If it was going down, it would be a negative. Good. So it says, so we've got two things here. We're going to use the knowledge we've got about perpendicular lines, but we also need to do something we have discussed, which is when the point is different. So we know that a line is perpendicular, straight line L. So this is line L, and we need to figure out the equation of it. Okay, so it's going to be a y equals mx plus c. How do I know it's mx plus c? Just because it's always a straight line is always mx plus c, yeah? All right. So what do I know about a perpendicular line? Well, the gradient here is related to this gradient here, which is the m, right? So what was the relationship that we discovered last lesson? So if this is 2, this one's going to be negative. Angus told us, what do? We take the number, we switch it and make it, it's not negative 3, it's got nothing to do with this number. What's this number got to do with? That's the y-intercept. So that's here, they're completely different. Look, if those were the y-intercepts, they're completely different numbers. Remember, it's the gradients that are linked. Ignore these two numbers, they've got nothing to do with the gradient. So how do I figure out? So if this is 2, remember it's rise over run. So 2 over 1. So this would be negative. Come on, guys. We did this last lesson. You sort of told me. What do? We take... Pardon? Negative 1 over 2. Good. So if it was 2 over 1... Remember, we swap the numbers. Now, I don't like writing it like that, but it seems to have made sense to you. There was one other thing that we could check. Do you remember? It should be on your notes, if we're correct. How do we confirm we've got the correct gradients?
Like
you got notes.
Like the squares, like how much it goes up by them?
No, how do I know that 2 and negative 1/2 are gradients that give me perpendicular lines? So at the moment I've got y equals negative 1/2 x plus c. How can I check that I'm right with those two numbers? There was one other thing that we could do. Should be in your notes. And get negative 1. Good. So if we did 2 for this one times negative 1/2, do we get the answer negative 1? Well, 2 halves is 1. So negative 1. So yeah, we're right. Now there is a correct way. So swap the numbers and change the sign is a bit of a rubbish way of saying, okay? What we have is use the negative, and you should recognize this next word from the graphs section we did, the negative reciprocal. Do you remember doing reciprocal graphs, reciprocal functions?
I've never even heard that one before.
You have. You've done it with me. Reciprocal functions were 1 over x. Yeah. It's not a word that we use very often, but it is a word that it's good to remember and understand what it means. So a reciprocal graph, I don't know whether you remember, we sketched them, we plotted them, and they look like this. You've got that side and
Oh yeah.
that side, and it was when we had y equals 1 over x, like this. So 2 or 1 over 2. So it's the reciprocal. Okay. So that's a link that you've done before, a reciprocal function. So what we do with gradients is take the negative reciprocal. That's step 1. Find the gradient. How did we find the gradient?
Use the formula.
What formula?
Y equals mx.
That's not how we found the gradient. That's how I knew.
In front of the two. Yeah.
Yes.
So the 2x, and how did I find the gradient of the the perpendicular one? Flip it and make it negative. Yeah? Just recapping. We still don't have a complete equation though. What have we got to find?
C.
The C, okay? So step 2, find C. So, any ideas how to do it? I suspect I'm going to get an answer that's incorrect, but let's see what you come up with. How could I find the C? I want to, is y equals a half x plus c. What's the C value?
Just the same. Like wherever it crosses.
Wherever it crosses the y-axis, yeah?
Yeah.
Yeah. I mean, you're right. C is where it crosses the y-axis. So where does our line cross the y-axis?
4, 7.
4, 7.
Yeah.
Okay. So is 4, 7 on the y-axis?
It's not.
No.
It's not like
It's a lot further.
thingy down. But
So it's
So
not.
Is it 0, 7?
Okay, so if it was 0, 7, that would be on the y-axis, yeah?
I feel like it's
But this is 4, 7. Is 4, 7 on the y-axis? No, right? That's important. Okay? So 4, 7 is the point we're going to use, but this is not on the y-axis. So C is not 7. Do you remember I talked about that sort of a couple of lessons ago? You wanted to just, oh, it's the number in the bracket. It's not. It is if it's 0, 7, but it's not 0, 7. So I did go through this, but just once. So just wondering whether you remember it or not.
It's like he times it. You put them in you do like the y is equal to mx, but you just put like if it was 0, then it'd be 0x.
Yes.
So this is 4, so it'd be y. This would be 4 in front of the x.
Yeah, good. So we've got this, look, we've got y equals negative 1/2 x plus c, and we know that when x equals 4, y has to equal 7. So when it's 0 and 7, we can do the same thing, we just don't need to, but this time we do. So what does that make this equation? It makes it 7 equals negative 1/2 times 4 plus something. Have you not got this booklet with you, Clinton? Okay, so let's do negative 1/2 times 4. So that's 7 equals negative 2. So now we've got a nice simple 7 equals so negative 2 plus something is 7. So what's the something? So the something has to equal 9. So we've got y equals negative a half x, which is what we had from the first bit, but now we've got a plus 9.
Sorry, can I get a tissue?
So 2x plus 3. We know that 2x plus 3 is a line that goes up, straight line, yeah? If it's parallel here means it's going to be another line, okay? And it's parallel, okay? So this is 2x plus 3, y equals. This one's going to be y equals mx plus c. But what do we know? Same gradient.
So it's 2x plus 6.
So this is the gradient of this line. This is the same. So I know that it's going to be y equals 2x plus something. It's going to be something different. How do I figure that out? Well, there's no 0c coordinate. We don't have that. So we don't have this. But we do have this coordinate, which is when x equals 3, y equals 2. So we can put that in. So 2 is equal to 2 times 3 plus c. So 2 is equal to 6 plus c. So c has to equal minus 4. So we end up with y equals 2x minus 4. Okay.
I got everything apart from the last stuff.
Good. So but now we've got y, m is minus 1 over 2. We've got y equals minus 1 over 2 x plus c. How do we figure out the plus c again?
Take coordinates.
So we've got the coordinates here, look. So when x equals 3, y is 2. So I'm going to go up here and I'm going to write 2 equals, so 2 equals, it's going to be a hard one, this one, minus 1/2 times 3 plus c. So this is going to be a trickier one numerically. Doesn't change anything mathematically, but numerically it's going to be a bit harder because we have to deal with fractions. Or you could turn to decimals, I guess. So what's 1/2 times 3? Okay, so this one might be easy to turn into decimals. So minus 1.5 plus c. So c has to equal 3.5. So we've got y equals minus, if we're going for decimals, 0.5 is our x plus 3.5.
You have like fractions and decimals.
Yeah, well, we wouldn't put them together. So, for instance, I would write minus 1 over 2x plus, and 3.5 is 7 divided by 2. I wouldn't, I mean, I'll be honest, in your exam, if you mixed up, they're not going to worry about it. They're not going to mark it wrong. But it's kind of like bad spelling in your English essays or whatever. You're not going to be penalised at this stage. Chord. Perpendicular, gradient is 3 over 2. So that means the gradient of the new one is going to be negative 2 over 3 x plus c. When x equals 3, y is minus 2. negative 2 is equal to negative 2/3 times 3 plus c.
It's equal to -2.
Negative 2 is equal to negative 2 plus c. Therefore, c is 0. So it's just y equals negative 2/3 x. We don't bother writing plus 0. If you do, it's not a big problem. Okay.